Hi! Today, we will learn about the graphs of quadratic functions. So our objective is to graph a quadratic function, determine the domain, range, intercepts, axis of symmetry, vertex, and the direction of the opening of the parabola. Let's have an example. Sketch the graph of y is equal to x squared plus 4x plus 1. So first, we will complete the table of values for x and y. Using the function y is equal to x squared plus 4x plus 1. If x is negative 4, so let us substitute negative 4 to x. Negative 4 squared is 16. Positive 4 times negative 4, negative 16 plus 1. 16 minus 16 is 0, plus 1, that is equal to 1. So if x is negative 4, y is equal to 1. Next, if x is negative 3, y is equal to negative 3 squared plus 4 times negative 3 plus 1. Negative 3 squared is 9. 4 times negative 3 is negative 12 plus 1. Negative 9 minus 12 is negative 3 plus 1, that is negative 2. So if x is negative 3, y is negative 2. Next, if x is negative 2, y is equal to negative 2 squared plus 4 times negative 2 plus 1. Negative 2 squared is 4. 4 times negative 2 is negative 8 plus 1. 4 minus 8 is negative 4. Negative 4 plus 1, that is negative 3. So if x is negative 2, y is negative 3. Next, if x is negative 1, y is negative 1 squared plus 4 times negative 1 plus 1. Negative 1 squared is 1. 4 times negative 1 is negative 4 plus 1. 1 minus 4 is negative 3. Negative 3 plus 1, that is negative 2. So if x is negative 1, y is negative 2. Then for the last one, if x is 0, y is equal to 0 squared plus 4 times 0 plus 1. So we have 0 plus 0 plus 1. Therefore, y is equal to 1. So if x is 0, y is equal to 1. So that is our table of values. Let's continue. Now, we will draw the graph or parabola by plotting the points in the Cartesian plane and connecting the points by a smooth curve. So we have negative 4, 1. Next we have negative 3, negative 2. Next we have negative 2, negative 3. Negative 1, negative 2. And then 0, 1. Okay, we will connect the points by a smooth curve. In the given graph, the graph of a quadratic function is what we call a parabola. It has a turning point called vertex, either the lowest point or the highest point of the graph. So in the given example, the vertex is at point -2, -3. So this is the vertex. Also what we call the minimum point in our parabola. The parabola may open upward if a is greater than 0, or downward if a is less than 0. So in the given parabola, since the function is y is equal to x squared plus 4x plus 1, the value of a is positive 1. Since a is greater than 0, therefore the parabola opens upward. Axis of symmetry is a line which divides the graph into two parts, such that one half of the graph is a reflection of the other half. So how do we show the axis of symmetry in our graph? The axis of symmetry is x is equal to -2. So this is our axis of symmetry. Remember, it divides the graph into two parts such that one half of the graph is a reflection of the other half. Next, the domain of a quadratic function is a set of all real numbers. It's the set of all x's such that x is a real number. So in the given quadratic function or graph, the domain is the set of all real numbers, while the range is the set of all y such that y is greater than or equal to k if the parabola opens upward. The range is the set of all y such that y is less than or equal to k if the parabola opens downward. Since the parabola opens upward, therefore the range of the quadratic function is the set of all y such that y is greater than or equal to the value of k, which is -3. If the quadratic function is written in the form y is equal to ax squared plus bx plus c, the vertex can be determined using the formula h is equal to -p over 2a and k is equal to 4ac minus b squared all over 4a. But if the quadratic function is expressed in the form y is equal to a times quantity x minus h squared plus k, the vertex is the point hk. And the line x is equal to h is the axis of symmetry, and k is the minimum or maximum value of the given function. So here are the properties of the graph of y is equal to x squared plus 4x plus 1. The opening of the parabola is upward, since a is greater than 0. The vertex is at point -2, -3. It's the minimum point of the parabola. The axis of symmetry is the line that divides the parabola such that half of it is a reflection of the other half. So x is equal to -2. The domain is the set of all real numbers. The range is the set of all y's such that y is greater than or equal to the value of k, which is negative 3. So in the given vertex, since the vertex is at point negative 2, negative 3, remember that this is our h, this is our k. Okay, let's have another example. Sketch the graph of y is equal to negative x squared plus 4x minus 1. First, we will complete the table of values for x and y. So using the function y is equal to negative x squared plus 4x minus 1. So if x is positive 4, let us solve for y by substituting 4 to x. So we have negative x squared plus 4x minus 1. Y is equal to negative 4 squared plus 4 times 4 minus 1. Negative of 4 squared is 16. 4 times 4, 16 minus 1. So negative 16 plus 16 minus 1, that is equal to negative 16 plus 16 is 0, minus 1, that is negative 1. So if x is 4, y is negative 1. Next, if x is equal to 3, so we have y is equal to negative 3 raised to the second power plus 4 times 3 minus 1. Negative of, what is the value of 3 squared? We have 9. 4 times 3 is 12 minus 1. So we have negative 9 plus 12 minus 1. Negative 9 plus 12 is 3 minus 1. We have 2. So if x is 3, y is 2. Next, if x is equal to 2, we have y is equal to negative, the value of x, 2 squared plus 4 times 2 minus 1. Negative of 2 squared is 4. 4 times 2, 8 minus 1. So we have negative 4 plus 8 minus 1. Negative 4 plus 8 is 4. 4 minus 1, we have 3. So if x is 2, y is 3. Next, if x is equal to 1, y is equal to negative of 1 squared plus 4 times 1 minus 1. Negative of 1 squared is equal to 1. 4 times 1, 4 minus 1. Negative 1 plus 4 is 3 minus 1, that is equal to 2. So if x is 1, y is equal to 2. And then for the last one, if x is equal to 0, y is equal to negative of 0 squared plus 4 times 0 minus 1. So that is equal to 0 plus 0 minus 1. So y is equal to negative 1. So if x is 0, y is equal to negative 1. So that is our table of values. So next, we will draw the graph or parabola by plotting the points in the Cartesian plane and connecting the points by a smooth curve. So first we have 4, negative 1. Next we have the point 3, 2. Next we have 2, 3. And then 1, 2. And for the last point, we have 0, negative 1. So we will connect the points by a smooth curve. So let's have the properties of the graph of y is equal to negative x squared plus 4x minus 1. So what is the opening of the parabola? So the parabola opens downward. Remember that if a is greater than 0, the parabola opens upward. If a is less than 0, the parabola opens downward. So in the given function, the value of our a is negative 1. So as you can see in the graph, it opens downward. Next, where is the vertex of the graph? The vertex of the graph is at point. This is the vertex of the graph. It is at point 2, 3. This is also the maximum point of our parabola. Next, the axis of symmetry. Remember that the axis of symmetry is a line that divides the parabola into two parts, wherein half of it is a reflection of the other half. In our parabola, this is the axis of symmetry, which is equal to x is equal to the value of h, which is 2. Therefore, the axis of symmetry is, we have x is equal to 2. Next, the domain. The domain is the set of all real numbers. Next, we have the range. Remember that the range is the set of all y such that y is greater than or equal to k if the parabola opens upward. If the parabola opens downward, the range is the set of all y such that y is less than or equal to k. Since the parabola opens downward, therefore the range of the quadratic function is the set of all y such that y is less than or equal to the value of our k, which is 3. Remember that in our vertex, this is our h, this is our k. So that is, or these are the properties of the graph of y is equal to negative x squared plus 4x minus 1. Let's have our third example. Sketch the graph of y is equal to quantity x minus 4 raised to the second power minus 3. As you can see, our quadratic function is written in the form y is equal to a times x minus h raised to the second power plus k. So with this, we can easily identify the vertex of the given function. Since the vertex is at point hk, so in the given quadratic function, h is equal to 4, k is equal to negative 3. Therefore, the vertex of the quadratic function is at point 4, negative 3. We can also identify the value of a, which is equal to 1. The question now is, how are we going to sketch the graph of the quadratic function without a table of values? Okay, this is something that we have to keep in mind. Always use the formula y is equal to ax squared. And then, let x be equal to 1 and let x be equal to 2. After that, solve for y using the given formula. In the given function, our a is equal to 1. So if we let x be equal to 1, let us substitute 1 to x. So we have 1 times 1. Therefore, if x is 1, y is equal to 1. Next, using the same formula, y is equal to ax squared. A is equal to 1, x is 2. Let x be equal to 2. So we substitute 2 to x. So we have 1 times 2 squared, that is equal to 4. 1 times 4 is equal to 4. So what are we going to do with this? Okay, first let us plot the vertex of our quadratic function. So the vertex is at point 4, negative 3. Okay. What are we going to do with x is equal to 1 and y is equal to 1? Or x is equal to 2 and y is equal to 4? What do we mean by these values? Okay, the value of the x tells us the number of units we need to move to the left and right of the vertex. And the value of y tells us the number of units we need to move upward or downward from the vertex. Okay. So if x is 1, y is 1, it means that from the vertex, we need to move 1 unit to the right and 1 unit upward. Since the graph opens upward, for a is equal to 1. So from the vertex, which is at point 4, negative 3, move 1 unit to the right and 1 unit upward. That will be the next point of the given parabola. Next, what do we mean by x is equal to 2 and y is equal to 4? It means that we need to move 2 units to the right and 4 units upward from the vertex. So from the vertex, we move 2 units to the right, 1, 2, and then 4 units upward, 1, 2, 3, 4. That will be the next point of our parabola. Same also on the other side or on the left side. If x is 1, y is 1. So we move 1 unit to the left and 1 unit upward. For the next point, we need to move 2 units to the left and 4 units upward from the vertex. 1, 2. So 2 units to the left and then 4 units upward. 1, 2, 3, 4. So this will be the next point of the parabola. Now we can connect the points by a smooth curve. So we now have our parabola, or the parabola of the function y is equal to quantity x minus 4 raised to the second power minus 3. With this, we can now identify the properties. So what is the opening of the parabola? The parabola opens upward since a is greater than 0 or a is equal to 1. The vertex is at point 4, negative 3. This is also the minimum point of the parabola. The axis of symmetry is the line that divides the parabola into 2 parts, wherein half is a reflection of the other half. The axis of symmetry is x is equal to the value of h, which is 4. So the axis of symmetry, we have x is equal to 4. The domain is the set of all real numbers. And the range is the set of all y's such that y is greater than or equal to the value of k, which is negative 3. Let's have another example. Sketch the graph of y is equal to negative 2 times quantity x plus 1 raised to the second power minus 5. As you can see, the quadratic function is written in the form y is equal to a times quantity x minus h raised to the second power plus k. So with this, we can easily identify the vertex of the parabola, which is at point hk and the value of a. So with this, the value of a is equal to negative 2. And the vertex is at point, the value of h is negative 1. And the value of k is negative 5. So we can now plot the vertex in the Cartesian plane, negative 1, negative 5. So again, the question is, how can we graph the function without a table of values? So again, we will use the formula y is equal to ax squared. So first, we will let the value of x be equal to 1, and then let the value of x be equal to 2. After that, we solve for y using the formula y is equal to ax squared. A is equal to negative 2 times the value of x, which is 1. So negative 2 times 1, we have negative 2. If x is 1, y is negative 2. Next, if x is equal to 2, let us solve for y. Y is equal to ax squared. A is negative 2, x is 2 raised to the second power. So we have negative 2 times 4, that will be equal to negative 8. So if x is 2, y is equal to negative 8. We are doing this to identify other points on the graph. So if x is 1, y is negative 2. What do we mean by that? We need to move 1 unit to the right and 2 units downward from the vertex. So if this is our vertex, the vertex is at point negative 1, negative 5. From the vertex, we move 1 point to the right, and then, or 1 unit to the right, and then 2 units downward. Since y is a negative number, it's negative 2. So 2 units downward. 1, 2. So that will be the next point of our parabola. Next, we have x is equal to 2, y is equal to negative 8. It means from the vertex, we move 2 units to the right and 8 units downward. Okay, so we have 1, 2. 2 units to the right, 8 units downward. 1, 2, 3, 4, 5, 6. Let's say we have here 7 and then 8. So this will be the next point of the parabola. Same on the left side. We move, okay, from the vertex, 2 units to the left, or 1 unit to the left, and then 2 units downward. 1, 2. And then again from the vertex, 2 units to the left, 1, 2, and then 8 units downward. 1, 2, 3, 4, 5, 6, 7, 8. So this will be the next point of the parabola. Next, let us now connect the points by a smooth curve. So this is now the graph of the quadratic function. Let us now identify its properties. So as you can see, the opening of the parabola opens downward. Since the value of a is a negative number, the vertex is at point -1, -5. The axis of symmetry is x is equal to h, or x is equal to -1. Sorry. The domain is the set of all real numbers, and the range is the set of all y such that y is less than or equal to the value of k, which is -5. So that is how we graph a quadratic function and identify its properties. Thank you very much.